Section 1.6, measuring center. So far, every time we've described a distribution using SOCs, we were kind of just eyeballing the center. And in this section, we're going to talk about different ways to identify a center and how to calculate those. So there's three main different measures of center. There's the mean, that's the average of all the individual data values. Okay, to find the mean, we're going to add up all the values and divide by how many values there are. After that, we have the median, which is the midpoint of the distribution. It's the middle. Half is smaller and half is larger than the median. To find the median, we need to order our values from smallest to largest. And then we're going to start crossing out from both sides. Okay, and if we have an odd number of data values, so if our sample size, which we denote as the letter N, okay, how many values there are in our data set. So if the sample size is odd, we're going to have just one number in the middle. That will be the median. If the sample size is even, then there's going to be two numbers in the middle, and we'll have to average those two middle values. And then lastly, we have the mode, which is the most frequently occurring data value. There can be multiple modes or no mode at all. So let's say we have a data set that has 4 1s, 4 3s, 4 7s, and then everything else has like 3 or less. We would have 3 modes. Okay, if we just have one of every single value, there is no mode because nothing happens more frequently than the others. We only want to use mode for categorical variables. It really doesn't tell us a lot. So if we were talking about, say, eye color, we might say the mode is brown. The most frequently occurring eye color is brown. But if we were talking about something quantitative, like say heights or GPAs, we would want to give a numerical representation of the center. We'd either want to find the mean or the median. So let's find some of these measures of center using this data set here. And this dot plot is showing a random sample of 20 New Yorkers who were asked how long it takes them to travel to work. All right, since there are 20 values here, N is our sample size equals 20. Okay, and it's a lowercase n because this is just a sample. It's not all the New Yorkers. There would be millions of dots here if it were all the New Yorkers. If this was all the New Yorkers, it would no longer be a sample. It would be a population, and we would use a capital N instead of a lowercase n. All right, so the mode, the most often occurring value, it already gave us that dot plot here, and we can see the peak right at 15. So that's our mode. Median, remember, we need to order these values first before we start crossing them out. So we want to put them in order, smallest to largest, and then we're going to start crossing out. All right, every one in the back, I'm going to do a couple at a time, just to save time. So 3 at a time, 3 at a time. All right, one more. All right, and we can see there's 2 values in the middle, which we knew there were going to be because there's an even number of values in our data set. So we would average those 2 values and get a median of 22.5. All right, the mean, the average of all the individual data values, we're going to add up all these numbers, and we're going to divide by how many there are, in this case 20. So we add them all up, we divide by 20, and we get a mean of 31.25. Now, one thing to note, which we're going to talk more about a bit later, is that the mean is a lot larger than the median, and that's because this distribution is skewed to the right. Okay? When a distribution is skewed, the mean gets pulled towards the skew, and the median is a better representation of the middle. Okay, some additional notation. The variable we use to represent the mean, we call x bar. It's x with a line over it. All right, and it really could be any variable. So if you saw y bar, y with a line over it, that would be the average of all the y values. Okay, and we use this for a sample. Again, we're not talking about all the New Yorkers. We're only talking about 20 of them who've been randomly selected. If we were talking about all of them, now it's about a population, and instead of using this variable here, we would use this one called mu. That's a Greek letter. Now, how do you know which measure of center you want to use? Well, here we have a couple different distributions just to kind of show how these relate to one another. All right, the mode we can pick out visually because it's the highest peak, but remember we always want to use that just for categorical data. Okay, so now in a distribution that's symmetric, like we see here in the middle, okay, the mean and the median are going to be pretty much the same. okay, very close to one another. Once we have a skewed distribution, like this one on the left, where it's skewed to the left, okay, it says up here the median is 19. All right, the mean's a bit smaller than that, closer to 18, because the mean gets pulled towards the skew. So it's getting pulled towards the left there because of these low values that aren't balanced out on the other side. Okay, we see the opposite of that over here. This one's skewed to the right. We have some high values that are going to pull the mean towards it. Mean is 4.14, larger than the median in the middle there, 3. Okay, so when we decide which measure of center to use, we want to consider the shape. Okay, we want to use the mean for distributions that are approximately symmetric. We want to use the median for ones that are skewed. Okay, here and here. Now I skipped over those 2 dots. Let me get back to that. The best measure of center is the mean. All right, and the reason is that we use every data value. Okay, it's using all of these dots in the distribution when we calculate the mean. All right, whereas when we use the median, we start crossing things out and we end up doing just the 2 in the middle. All right, so that's why the mean is quote unquote better, but we only want to use it for those distributions that are symmetric. All right, median we use skewed. Okay, median's called resistant to extreme values, meaning if we have an outlier, let's say there was one value in this one that was like 100, way out to the right, it's going to change the mean, the median very, very slightly. Okay, so it might switch it from 3 to 4. All right, but the mean would get pulled close or pulled far to the right towards that outlier value. So a median isn't really affected by outliers, affected very minimally or not at all. That's why it's called resistant. All right, and then mode, as we noted, we want to use only for categorical distributions. Now to reiterate that point, we have 2 displays here. The dot plot on the left here is showing EPA mileage estimates in miles per gallon for 21 mid-size cars in the year 2020. Okay, we can see there's this one outlier way at the top here. Okay, and then on the right, we have that same distribution with that outlier removed. Okay, so looking at the graph on the right first, we can see the mean. Okay, X bar is the mean of the sample, and the median both around 21. So now, ignoring the dot plot, just looking at these values, the fact that these are the same is telling us that this distribution is approximately symmetric. And I mean, it doesn't show us that bell shape that we really ideally would see, all right? But it is approximately, quote unquote, symmetric. The one on the left here is skewed to the right because of that single outlier. And that one outlier is pulling that mean to the right. Okay, so it's pulling it larger than the median. So the median, largely unaffected by outliers, whether that outlier is there or it's not there, doesn't change the median at all. Okay, if it did change it, it would change it slightly, might bounce it from like 21 to 22, all right, or for an outlier on the low side, it might drop by 1 or a half, but largely does not change the median once we have or remove an outlier. That's why it's called resistant to outliers. And the mean is affected by outliers and other extreme values. It's pulled towards that direction, okay, just like it's pulled towards the tail in skewed distribution. And it's labeled non-resistant to outliers. Lastly, let's describe this distribution. And of course, we want to do SOX again, shape, outlier, center, spread. And now we have a bit information about the center. So when we choose a center, we want to look at this shape. Okay, we see that it's skewed to the right. And because it's skewed to the right, we want to use the median as the center. Okay, if it were approximately symmetric, then we would want to use that mean there. Distribution of gas mileages for 2020 midsize cars is skewed to the right with a median of 21, a range of around 35, and one high outlier at 51.